Hello and welcome to our first lesson in Math 100B, Factoring and Lowest Common Multiples. But before we start, let's take a look at this quote by President Eyring about uniqueness. He says, and I quote, "Each of you is a unique child of God. God knows you individually. He sends messages of encouragement, correction, and direction fitted to you and to your needs." End quote. This message is powerful. There's over 7 billion people in the world. And it tells us that our Heavenly Father knows us individually. And we have the ability to receive revelation from Him that will help us through hard times and help us get to direct our lives. This is powerful. One additional thing it talks about is unique. We're each unique through our experiences, the talents we have, or even biologically. We're different. We have specific genes and unique DNA. No two people are alike. And that's very important. We're going to also apply this idea to numbers. Let's take a look. All numbers have a unique code or a DNA to them that makes them all unique. That can be found by finding what is called the Prime Factorization. We can create a number tree and break down numbers into their genes or their primes, as we call them. Let's take a look at the number 20. We can break the number 20 down into, 2 times 10. This number doesn't break down anymore, but 10 does. 10 can break down into 2 times 5. Notice these numbers here no longer break down, and that makes them unique. We call these numbers prime numbers. Prime numbers are numbers that can only be divided by themselves and 1. Let's take a look at a couple other primes. The very first prime is 2. 3 is a prime. 4 is not a prime because it can be divided by 2. But 5 is. 7. Not 9, but 11, 13, and so on. These numbers can only be divided by themselves and 1, which makes them unique. It makes us allowed to realize that every number is built out of primes. Notice that 20 is built out of 2 times 5. We could also write this as 2 squared times 5, since there were 2 2's. And this right here is the code of the number 20, the uniqueness. No two numbers will be alike. No two numbers code and prime factorizations will be alike. Let's take a look at another example. So let's take a look at another few examples, like the number 70 and the number 124. Remember, you can use a calculator in this class, so if you get stuck and you need another to figure out what divides into what, feel free to bust out a calculator. I'm going to go ahead and take out 2 out of 70 because I know it's even. That gives me 2 times 35. 35 breaks down into more. It's 5 times 7. And so that's it. None of these numbers break down more. And so the primes that make up the number 70 are 2 times 5 times 7. This is the code that makes up the number 70, the prime factorizations. Okay, let's try number 124 here. 124 is 2 and 62. 62 breaks up into 2 and 31. And 31 doesn't break up any further. So our prime factorizations would be these two. So 2 squared times 31. Excellent. So now it's your turn. Let's take a look at these problems. So here are some problems for you. What we'd like you to do is stop the video and take out your video notebook and work on these 3 problems here. We want you to find the prime factorizations, the code of these numbers out of primes. And so we'll let you go ahead and pause the video now and work on those in your notebook. And when you're ready, go ahead and push the play button again, and we'll go through these to see if you got them right. Good luck. Okay, welcome back. We'll go ahead and work on these problems here. I know that 56 is 8 times 7. 8 breaks down into 4 and 2, and 4 breaks down into 2 and 2. So we have 2 3's, so I would write 2 cubed times the number 7. That's the prime factorization of 56. Let's try 120. 120 is 12 and 10. 12 is 6 and 2. 6 is 2 and 3. 10 is 2 and 5. I'm going to go ahead and underline these primes here so that I don't double count them. I've got 3 2's, so I would write 2 cubed times, I've got a 3, times, got a 5. This would be the unique code, the prime factorization, for the number 120. Let's look at 24 here. 24 breaks up into 2 and 12, which is 6 and 2, which is 2 and 3. We have 3 2's, so I would write 2 cubed times 3. That's the prime factorization of 24. How'd you do? Hopefully you did good. Let's try a couple more. Here's 3 additional problems to give a try. 49, 150, and 37. Pause the video and give these 3 a try. When you're ready to start over, push the play button. So the only numbers that go into 49 are 7. You get 7 times 7. And so the prime factorization is simply 7 squared. 150 breaks up into 10 and 15. Again, you could have done that differently. You could have said 2 and 75. You would get the same answer. 2 and 5, 3 and 5. And so we get 2 times 3 times 5 squared. That's the prime factorization of 150. Now 37 should have been a little harder. You may have had to bust out your calculator and try a couple things. But it turns out that 37 is a prime number. And so the prime factorization of a prime number is simply 37. Nothing goes into 37 except 1 in itself. So that was a little trick problem. Remember that the prime factorization of a prime number is just prime. Okay, let's move on to the next part of the lesson. We now want to work with lowest common multiples. Lowest common multiples is the lowest value that both numbers can go into. For example, if we took a look at the numbers 8 and 10, and I said, okay, what's the smallest number that both 8 and 10 can go into? Well, one way to do this is to write out the factors of each number, so the multiples, I should say. So 8, 16, if we added another 8, we get 24. Add another 8, we get 32. Add another 8, we get 40. Add another 8, we get 48. Add another 8, we get 56, and so on. We could also do that with 10. 10, 20, 30, 40, 50, 60. And what you want to do is look at these columns and say, okay, what number do they have in common? What's the lowest common multiple? And you'll see a value right here, 40, appears in both of these columns. And so it's the number 40 that both 8 and 10 can go into, and that represents the lowest common multiple. Let's have you try a few by writing out the columns. So we'll start off easy. Let's see if you can find the lowest common multiple of 4 and 5. We want you to write out all the multiples and find out which one is common. Once you're done with that one, try this one, 3 and 15. See if you can find the lowest common multiples. When you're ready to check your answers, resume the video. Okay, great. So you should have written out the multiples. We would have 4, 8, 12, 16, 20, 24, 28. You could have kept going, but I'm just going to go that far. Then we would have had 5, 10, 15, 20, 25. Ooh, I see one that's common already. Here it is. The lowest common multiple, 20, appears in both. And so the LCM of these numbers would be 20. Let's check it out with 3 and 15. It would be 3, 6, 9, 12, 15, 18, ... Here we would have 15, 30, 45. Ooh, and I see one already. Here, the number 15 appears in both. And so the LCM of these two numbers would be 15. The other way to find a lowest common multiple is actually to use the code, to use the prime factorization of the numbers. And so let's take a look at an example 8 and 12. We can find the lowest common multiple by finding the prime factorization. So I'm going to find the prime factorization of 8 by breaking it up. And notice I get 2 cubed. And then I'm going to find the prime factorization of 12, which is 4 and 3, 2, 2. So it's 2 squared times 3. So to find the LCM, what we would do is list out any prime numbers that we have. So 2 is a prime number, and also 3 is a prime number. And then you write down the number, the largest number of those primes that appears. So if we were to look, for example, here at the 2's, we had 2 cubed and 2 squared. Which one's the largest? Well, it's 2 cubed. So we would write 2 cubed in. I would then look at the 3's and see which one's the largest. Well, 3 to the 1 is the largest. And so that is going to help us find our LCM. We simply from there go ahead and multiply this out. 2 cubed is 8 times 3, which is 24. The LCM between 8 and 12 is 24. Let me do one more example of those, and then we'll let you try some. Let's work with the number 18 and 40. So again, you could create a list. That's one way to do it, but I'm going to go ahead and find the prime factorizations. It'd be 9 and 2 and 3 and 3. 40, I'm going to do 4 and 10, which would be 2 and 2 and 2 and 5. So to find the LCM, I'm going to list any prime that's available. I see a 2, all the primes. There's a 3, and there's also a 5. I then want to list the largest amount that there are. So this one was 2 times 3 squared. This is 2 cubed times 5. So I'm going to write down the largest one. So what's the largest number of 2's I have? Well, that would be 2 cubed. What's the largest number of 3's I have? Well, that would be 3 squared. And what's the largest number of 5's I have? Well, that would just be 1. So then I can multiply those out together. So 2 times 2 times 2 times 3 times 3 times 5. I would use a calculator here. Remember, you can use calculators. So 2 times 2 times 2 times 3 times 3 times 5. The LCM of these are 360. Okay, so it's your turn to find some LCMs between two numbers. We'd like you to find the prime factorizations and then identify what the LCM would be. We want you to find it between 18 and 30, and also the LCM between 24 and 36. So again, write the prime factorization tree, and then identify the LCM by writing out each of the primes and the largest number of times they appear. Give it a try in your notebook, and when you're ready to check your answers, press the play button. You can pause now. Okay, so let's see how you did. This is 9 and 2. This is 3 and 3. 30 is 3 and 10. And 2 and 5. So the prime factorizations here are 2 times 3 squared. And this one is just 2 times 3 times 5. So to find the LCM, I'm going to write all of the primes I see available. That's 2 and 3 and 5. And then write the largest amount that appear in any single one of the numbers. So 2 to the 1 is the biggest. 3 squared works, and 5. And so our final LCM then would be 2 times 3 times 3 times 5. The LCM would be 90. Again, you could have done this by writing out all the multiples, but this is just another way of doing it using the prime factorizations. 24 is 8 and 3. 8 is 4 and 2. And 4 is 2 and 2. So we get 2 cubed times 3. As for 36, that's 9 and 4. 9 is 3 and 3 and 2 and 2. So it's 2 squared times 3 squared. These are the prime factorizations. To get the LCM, we would want the largest amount of each prime. So the largest amount of 2's I see is 2 cubed, and the largest amount of 3's I see is 3 squared. So the LCM would be 2 times 2 times 2 times 3 times 3. I typed that into my calculator, and I got the answer of 72. That's the LCM. Okay, well, nice work. that is the lesson. It's now going to be your turn to work on the assignment. When you feel you're ready, go in there and do it. And if you have any questions, please contact your teacher or a tutor. We'd love to help. Thanks.